Hello. Next question. For the circuit shown with R1 equal to 1 ohm, R2 equal to 2 ohm, E1 equal to 2 volt and E2 equal to E3 equal to 4 volt, the potential difference between the points A and B is approximately in volt. You are given 4 options. Option A 2.7, option B 2.3, option C 3.7, option D 3.3. So 4 options are given. We have to do this problem. So we will see the easiest method to do this. Easiest method. See here, this is R1, this is, I am going to apply Kirchhoff's voltage law. This is R1, this is R1. In this branch, they are in series. So either you can keep them as 1 ohm and 1 ohm, or just for convenience sake, so that you may not do any mistakes. So you just put both resistance as one resistance and take the resistance as 2 ohm. So this is not there. Let me use the duster. Okay, this is 2 ohm. They are in series. Again same thing, R1 and R1, so 2 ohm. R2 by itself 2 ohm. E1 given to be 2 volt. E2 equal to E3 equal to 4 volt. Okay. Now you can apply E3 is also 4 volt here. This is 2 ohm. Right. Now you apply KVL. Even to apply KVL, you just think of a small thing. See here, 4 volt 2 ohm, 4 volt 2 ohm. This is singled out separately here. These two have identical EMF values and resistance values. So there is no reason why current flowing in this branch should differ from the current in this branch, because 4 volt 2 ohm, 4 volt 2 ohm. So you take the current here as I, current here as also I. These two current will combine here, then the current flowing through this way will be 2I. That is indirectly using KCL. So I and I will be equal to this 2I. After that, one single step you have to take to find the value of the current. After you find the value of the current, you can find the potential difference between A and B. So how to find current? Apply KVL to this loop. Okay, start from A, go anti-clockwise and come back to A. So start from A, go to this. So 2 into 2I, 4I, plus 2, minus 4, plus 2I, okay, equal to 0. 2 into 2, 4I, plus 2, minus 4, plus 2I is 0. So here you get 6I, minus 2, 4I plus 2I, 6I, 2 minus 4 minus 2 is 0, which gives you 6I is 2, again which gives you I, which gives you I is 2 by 6, which is 1 by 3 ampere. So the value of the current I is 1 by 3 ampere. Now we have to find potential difference between A and B. So if you consider this as the internal resistance of the cell, just an assumption of course, because nowhere in the question it is mentioned that the internal resistance of the cell, but it will amount to the same thing. So let's say if you take this as internal resistance, because any internal resistance of the cell we show them to be in series with the cell. That's how we represent any internal resistance in the cell. Okay. So if you take this as the internal resistance of the cell, and this is the EMF value of the cell, what we are going to find out is terminal PD of the cell. For any cell delivering the current, EMF will be greater than terminal PD. So what is EMF? E greater than terminal PD means E plus IR. Small r I have used here because it will represent internal resistance. Okay, but our aim is to find terminal PD between this A and B. So V is equal to E minus IR. E how much? 4 minus I how much? 1 by 3. R how much? 2 ohm. So this is 4 minus 2 by 3, which is equal to 12 minus 2 by 3, which is 10 by 3 here. So the answer would be 10 by 3 volt. So approximately this will be 3.3 volt. So option D will be correct. See, the problem is simplified. See, if you are given any problem, you see whether you can use or whether you can simplify it. So here 4 ohm, 4 volt, 2 ohm, 4 volt, 2 ohm. So current should be same. So I and I. Otherwise you will be taking I1, I2 and I3, or I1 and I2, then I1 plus I2, everything will come. Here because of this. So if it is I here, it has to be I here. 4 volt 2 ohm, 4 volt 2 ohm. This is of course a different value here. Therefore, in one equation itself we are able to solve for I. So final answer, option D, 3.3 volt. Okay, thank you.